Today we're going to talk about transformations of quadratic functions. The most basic quadratic function is y equals x squared. What does that look like graphically? It's a parabola. Actually, let me draw it like this. Like that. Okay? And then we can start making transformations on that. If I had y equals x minus 1 squared, what would that parabola look like? So, does that 1 affect the x or the y? It's on the inside, so it affects the x. And x's are the left-right movements, right? The x-axis. And you need to remember that everything that happens on inside on the x is backwards. So it says x minus 1, so you think all of the x's would get smaller by 1, which is actually what happens. But then when you plug them in, you get the answers that you would of something that's further to the right. So x minus 1 actually moves right 1. Same shape, it just got shifted right. Okay? What if I had y equals x squared minus 2? That one affects the y values. It happens outside of the x, after the squared. So we're going to move down 2. The shape is identical. Okay? So what about y equals x plus 1 squared plus 3? Left 1, because the x's are backwards, and up 3. Does it matter if I go left 1, up 3, or up 3, left 1? If I were to draw a parabola, I could go left 1 and up 1, 2, 3, and I'd land right there. Or I could go up 1, 2, 3, and left 1. Is that the same place? Yes. Does it ever matter what order you do them in? Yes. If there's a reflection, then the order sometimes matters. Okay? So what about y equals negative x squared? It flips all of the y values. So all of the positive y values rotate down and they become negative y values, and the negative y values become positive. So it ends up just being upside down. Let's put all three together. Y equals negative x plus 2 squared minus 1. Now the order matters. And you always start on the inside and work your way out. What is the first thing that happens to x? Left 2. So I'm going to go over here to 2. And then what happens to the x? Well, it gets squared. That tells us the shape. And then it flips. According to order of operations, you would do the subtract 2, then you would square it, then you would make the negative, and then you would subtract the 1. So now it flips upside down, and now it goes down 1. Watch what happens if I do that in a different order. So let's say this is my graph. Let's say I flip it. Well, actually, let's go down 1, and left 2, 1, 2, and now I flip it. But you need to remember, you always flip across that axis. So when you flip that, it ends up being too high. Does that make sense? So work your way from the inside out. Now, I hope they don't do any y-axis reflections. Let me look in the book. If they do, that causes some problems. Usually we just avoid that. Okay, we're on 2.5. We're good there. Ooh. Okay, it looks like they do y-axis or x-axis movements. That's okay. They do introduce what I was going to talk about, but they avoid the hard problems. So what about y equals 3 x squared. What's that going to do? Well, am I affecting the x values or the y values? Do you understand what I mean when I say that? So if I had a table of values, and this is x, and this is f of x, which is x squared, or y, 0 would give me 0, 1 would give me 1, 2 would give me 4, 3 would give me 9, and so on, right? Is that 3 going to change this column or that column? Does it happen before the squared or after the squared? After the squared, which means it's going to affect this column, which means it's going to affect the graph along the y-axis. So what happens when I multiply all of the y's by 3? Well, I have this graph here. So negative 1, 1, that's one of the points. But now I'm going to times this whole list by 3. So I get 0 and 3 and 12 and 27. So this number here is normally up 1, but now it's going to be up 1, 2, 3. And this one is going to be up 1, 2, 3. And this one is going to be 3 times higher. And this one is going to be 3 times higher. And I end up with this. How would you describe that? We would say skinnier, but how did I perform the movement? I made it taller. It looks skinnier, right? But it's not. It's taller. It's taller because I changed the y values, not the x values. Right? I didn't pull it or push it along the x-axis. I pulled it along the y-axis. So there's a difference between taller and skinnier. Okay? All right, let me show you another one. What about y equals 1/4 x squared? Is that happening on the inside or the outside? Outside, so it affects the y values. What happens when I multiply every y value by 1/4? Not taller, shorter. Right? Smaller, we'd say smaller, but we mean shorter because we're affecting the y values. So if this were my original parabola, this point is going to be cut into a fourth. Right? This point gets dragged down to there. And this point gets dragged down to there. And this point gets dragged down to here. And we end up with something that looks wider, but wider is incorrect. Wider does not describe the movement that I created. I made it shorter. I smashed it down using the y values. Does everybody get that? Okay. Grades? Right on. Okay, I'll hand these out in a minute. Okay, let's do something a little bit different. What about y equals 2x squared? Is that happening on the inside or the outside? Inside. So what happens when I multiply all of the x's by 2? You would think wider. If I grab the x-axis and I made it twice as big, you'd think I would stretch it this way. But the x's always work backwards, right? Right is left, left is right. So stretching is actually shrinking. So we're going to make it twice as skinny. Okay, so let me graph the original. The original will look like this. And now I'm going to move them in by 1/2. Right? So right here and here. So basically I'm just taking the halfway point between those. And then I draw it. It looks skinny. But skinny does not describe the movement that I made. Okay? The y values either get taller or shorter, and the x values either get wider or skinnier, but the x's work backwards for everything. They work backwards for left and right. They work backwards for wide and skinny. And then you can reflect it across the y-axis. right? You can reflect this way, but if you reflect across the y-axis, nothing changes, right? If I took x squared and I reflected it, I'm going to end up with the same graph. So it doesn't look like they put one of those in there. All right, so here's a question. Is this equal to this? If I make a parabola twice as tall, is that the same as making it twice as skinny? What do you think? If I graph both of those, is there going to be a difference? Well, let's look. So 2x squared. Wow, that's bad. 2x squared, and then the quantity 2x squared. When I graph it, oh, that's not going to work. Zoom standard. That didn't work. So here's my regular parabola, or that's my 2x squared parabola. And then this is quantity 2x squared. So in this case, thinner is actually more powerful than skinny. And the reason is, what is 2x times 2x? 4x squared. So it turns out that twice as skinny is identical to 4 times as tall. Does that make sense? So there is an equality in there, but twice as skinny is not the same as twice as tall. All right, what about this? Y equals 1/3 x quantity squared. What's going to happen with that graph? It's going to be 3 times wider. So if I took my original parabola and I measured this distance, then I measure that distance out 2 more times. So 1, 2, 3, 1, 2, 3, and I start connecting dots, and I end up with a parabola that's wider. Okay? So what you need to remember is anything on the inside changes the x-axis, left, right, wide, thin, and those are always backwards. Anything that happens outside of the squared affects the y values, and up and down are just plus and minus, and then tall and short are just integers, or larger than 1 and smaller than 1, and then the negative will flip it upside down. Does that make sense? Okay, so in your student journals, turn to 1.5. And we're just going to do some matching. Oh, these aren't matching. Yeah, they are match. Yeah, 1.5, or 2.5, sorry. 2.5. So we need to match the little letters with the big letters. And if we look at little a, what movement is happening to little a? So is it flipped or slid first? Slid right, upside down. Now in this case it's not going to matter. But just remember you should work from the inside out. So we're going to go right 2 and be upside down. Do I have a graph that looks like that? D. Good. Okay, letter B, what's happening there? Right 2, up 2. So that would be graph C. Good. Little c, left 2. Nope. Left 2, upside down, down 2. Do I have a graph that's left 2, upside down, down 2? A. Good. Then letter D. Right 2. If I times the outside by 0.5, am I going to affect the x-axis or the y-axis? The y-axis. What happens when you multiply by 1/2? You make it smaller, you cut it in half. So right 2, this right here is right 2, and that will be half as half as tall. It's shorter. Yep. It's not wider or thinner, it's shorter because we're affecting the x values. Half as tall, or 1/2 shorter. Whatever, however you want to say that. And then down 2. Do I have one like that? Letter F. So you can see this one looks a little bit wider. But wider is the wrong word. It's shorter. We haven't changed the x's. We've just compressed the y's. All right, letter E. Nope. Right 2 and twice as tall. Yep, right 2 twice as tall. Okay? And then F, left 2, upside down, and up 2. So left 2, upside down, and up 2 would be letter E. Okay? So, if you look in your book on page 75, or just look up here, it talks about reflections. So a negative on the outside just takes this graph and folds it over to create the red graph. Okay? But if you have a negative on the inside, like this, then this side is going to move over there, and this side is going to move over there, and we end up with exactly the same thing that we started with. Okay? All right, and then horizontal stretches and shrinks. If I multiply on the inside, it's either going to get wider or thinner. How do I make it thinner? What numbers do I need to use to make it thinner? So remember, the x's work backwards. So what number could I multiply on the inside to make it thinner? Anything greater than 1. 1.5, 2, 3, 8, 95. As long as you multiply by a number bigger than 1, it's going to get thinner. How do I make it wider? You multiply by a fraction, and when we say fraction, we mean a number less than 1. Right? 5 over 4 is a fraction, but it's not less than 1. So we just mean a number less than 1. Okay? And then vertical stretches and shrinks. How do I make it taller? What numbers make it taller? So we're multiplying on the outside. If we multiply on the outside, what numbers are going to make it taller? Anything bigger than 1. And then anything smaller than 1 would make it shorter. What if you multiply by 1? It stays the same. Whether you multiply on the inside or the outside by 1, that doesn't change anything, so it stays the same. Okay. So writing transformations. If I wanted to create a quadratic equation that is right 3 upside down, and then half as tall and down 4, what would the equation be? What would I do to write that equation? Negative 1/2 squared minus 4. Does everybody understand that? You guys good? Anybody not get that? Do you need another one, or are we okay? Do another one? Okay. So let's say 3 times as wide, and then so 3 times as wide, upside down, and up 2. How do we make it 3 times as wide? So do we want to change the x's or the y's? If we want to make it wider, we want to change the x's. So we're going to multiply x on the inside by 1/3 because the x's are backwards. So 1/3 and then squared. Oh, upside down, thank you. And then plus 2. Do you want to see another one? Okay, let's go 3 times as tall. Oh, well, these are out of order, sorry. 3 times as tall, right 2, and down 3. Let's not do 3, let's do 4. So times by 3 is going to go on the outside because taller affects the y values. So 3 minus 2, good, squared, minus 4. Morgan, you doing okay? All right. Do you want to see another one, or are you good with that? Okay. So I would like you to do 1 through 43. Ooh, no, 1 through 45, odd. So 2.4, or no, 2.5, 1 through 45, odd. All right, good luck.